Okay, so today we're talking about normal distribution and the different types of distribution that we can have based on data sets. So here we have a wonderful chart that shows the number of babies, their birth weight, their birth month, what month they were born, their weight, and then their mother's age. Okay, and we're going to graph those on the number lines that they've given us. So let's start with the birth month. So the first baby was 5, so just going to put an X above 5. Then 7, then 11, then 2, then 10, then we're at 3, and then 1, 4, 7, 6, 9, 10, 11, 1, 6, 5, 8, 9, 12, and 2. Okay, we're going to do the same thing for birth weight now. Okay, so everyone fill in these charts for me. Okay, so this is what my distribution looks like, or my line plot. Okay. So we now need to talk about the shape of the distribution of the birth months, describe the shape of the distribution of the birth weight, and describe the shape of the distribution of the mother's age. So everybody write something about the different types of distribution you see. What does the birth months look like? What does the birth weight look like? What does the mother's age look like? Okay, Noah, describe the shape of the distribution of birth months. Oh, okay. So what's that have to do with the shape? 5, 6, and 7. We have a little bit of a dip. Okay. Brett, what did you say about the shape of the birth month?
I just said it was evenly distributed.
Okay. It's about the same, right? It's all kind of about 2s, a couple 1s here. Okay, but it's about the same. Evenly distributed is a good way of describing it. Let's see. They're going to call it uniform distribution. Okay, so make sure you have that word down. Whatever you wrote is fine, but uniform distribution is how they're going to describe it. Okay, Tanner, describe the shape of the distribution of birth weights.
They were about 3.2 to 3.7.
Okay, so most of the data was in between 3.2 to 3.7. Okay. Dan, what did you say?
The mother's age?
Oh, so for same with birth weight.
Oh, birth weight. I have to put it comes to a pyramid.
Okay, it's kind of like a pyramid or a hill. Okay. They call this normal distribution. Most of the data is in the middle at the mean. Okay. And it's symmetric. Has symmetry. Okay? So it's matching on either side of the mean. The mean is the highest. Okay. Those are the two key things. Normal distribution, okay, and it has symmetry. Okay. Serenity, what about the distribution of the mother's age? Okay, 29 and 30 were where we had most of our data. Carrington, what did you put? Okay, yes. It's kind of like this distribution, but it kind of has like a little tail here. Right, it kind of stretches out this way, because there's 1, 1, and then this random person over here. Okay? So this is what we call skewed to the right. Because this data here on the right-hand side is pulling the mean away from the majority of people. Okay? Let's see. So this is skewed. What they call skewed right. It has a tail on the right. Any questions over that? Okay. Now in the back, we're going to show you how to use your graphing calculator to find the mean, the median, the standard deviation, and the interquartile range for the baby's weight and the mother's age. Okay, so what we did in 12.4, where we calculated the mean, the standard deviation, our calculators will do that for you. And again, who's taking stats next year? Okay, this is something you will do all the time. Okay, you'll use these calculators and you will find the mean, the standard deviation, all this stuff in your calculator. So this will be good practice for you guys. So we're going to pull up our calculator. Okay, I'm going to go home. Okay. I want a new spreadsheet, so we're going to hit this button right here. And you should get this. I'm going to go all the way up to where it says A. Go to A, not the equal sign. A. And we're going to label it with what we are doing. The first one we're going to calculate is the birth weight. So you can just title it, let's just use W for weight. You want to title it something so you can find it again. Then arrow down, do not go to the equal sign. Okay. Go to number 1 and type in all of the values for the birth weight. 3.3, 3.6, 3.5, 3.4. You may already have this already entered there for you. If not, type it all in. I'm going to go back over here to B, and I'm going to put in A for age. Go past the equal sign, go to number 1, and then enter all of the mother's ages. Okay, so now we're going to add a new page. How you do that is you're going to hit the control button, and then do you see the plus page up here? Plus page. So control doc, and it'll get you to this. Anyone not here right now? Everyone's with me? Control doc. Huh? Escape. What did you do?
I don't know.
What did you hit?
Control.
Okay, escape. Delete. Oh my goodness. Home. Okay. There you go. Okay. Okay. Everyone's there? Okay, hit number 1. We're going to add a calculator page. Number 1. And it's just giving you a blank page like this. Okay. Okay, so that's what you're going to do with me. Okay. So then for, you're going to hit menu. Just hang out there until I tell you where to get to go. We want number 6 stats. So hit number 6. And then you should get this another one open, this other list. We want stats calculations, number 1. Then we want 1 variable statistics. So do you. Number 1. Hit number 1. Anyone not there? Now you should have this. Anyone did not make it there? Okay.
Like, switching them around, so, like, I don't even know where I am.
Okay, hold on. Okay, this is fine. Then you can search. Okay. Everyone with me? Yes, 1, and then 1 again. Everyone else is there. Okay, hit OK. Number of lists, we just want 1 right now. Okay, then you're going to tell me what list we want. We're going to do W first. Your list W. And then hit OK. And it will do all of this math for you, which is super nice. Okay, so right here, remember the X with the line above it is the mean. So 3.5 is the average weight. Okay, then the sum of all the weights was 70. Then the sum of all the weights squared was this. We don't care about those numbers. This is the sample. This is the population, and we're going to use this one for our standard deviation. Okay, remember that little Greek symbol sigma is our standard deviation. So on your paper, you should be writing this stuff down. 0.14. Then it gives you the median of X, which was 3.5 as well. It gives you quartile 1 and quartile 3, which is helpful for interquartile range. Okay. So let's pull this up. Yeah. So we got our mean to be 3.5. We got our median to also be 3.5. Then our standard deviation is 0.1449. Okay. The interquartile range on it was 3.6 minus 3.4, which is 0.2. Any questions over that? Okay. So our calculators would do this all for us, which is really nice. Because you guys all did standard deviation 12.4, which was lots of fun for us to do by hand, right? And it did for us in a matter of seconds. Okay? So now let's go back to our calculators. Because now we want to do the same thing for the mother's age. So you're going to go back to your menu. You want number 6 again, statistics. You want stats calculation. And again, you want one variable. You want the number of list, which is just 1. So hit OK. And then we're going to enter which list, whatever you labeled it. A. I labeled it A. If you labeled it something different, hopefully you labeled it A. And we're going to hit OK. And it's going to calculate it again. Okay, so we got our mean to be 31.15. We have our standard deviation of 2.6. We have our quartile 1 to be 29, our median to be 30.5, and our quartile 3 to be 32.5. Okay. So we want to go here and write those in. What was the mean, class? 31.15? The median was 30.5, right? No, that was for this one. We're doing age. Okay, the standard deviation was 2.6. And what was quartile 3? What was quartile 1? And so what does that give me? Any questions over that? Okay. So that's how you can use your calculators to find all this data for us. Okay, now answer this question. What do you notice about the mean and the median symmetric distribution or normal distribution, baby weights, as compared to the mean and the median for the skewed distribution, the mother's age? Explain why this happens. Okay, if you look here, this is the normal distribution, or the symmetric distribution. Okay, 3.5 is the mean and the median. The standard deviation is very small. The interquartile range is very small. Okay? With the skew data, we have 31.15 as the mean, and the median doesn't match it. Okay? Because the mean is being pulled to higher numbers because we have that 39 for sure, and then 34 and 35, I think, is the other two that are just singles. Okay? Then the standard deviation is bigger, and the interquartile range is also bigger because of our wider range with the 39 and the 35, 36 data. What is it? 35 and 34, the other two, larger numbers. Okay? Does that make sense? If you have a normally distributed data, then the mean and the median will match. Your standard deviation will be smaller, okay, when the range is smaller. Okay. So write something like that for D. Any questions over that? Okay, normal distribution. You want to draw a picture there for me? Let's go back. Boo, hold on. Okay. So this is our mean here, and we've kind of drawn this picture in 12.5. We were looking for standard deviations, and the number of standard deviations, not 12.5, that would be 12.4. The number of standard deviations away from the mean the values were. Now we're going to add percentages. For normal distribution, there's a certain percentage of your data that will fall within one standard deviation above and below it. Okay. So draw this pretty picture, and then we'll write in the percentages. This is where we get a curve, a bell curve. It's from normally distributed data. Okay, so again, the symmetry is here. Here's the mean, X with the line above it, mean. And one standard deviations above should have 34%. And one standard deviation should also have 34% of your data fall there. Therefore, 68% of our data should be within one standard deviation away from the mean. Any questions over that? Then 13.5 is within two standard deviations. And then the same thing on the other side, because there's symmetry. Okay. Then within 3 standard deviations, this is 2.5%. And 2.5%. And from here to here, that would be 95% will fall within 2 standard deviations, and then 100% with all of it. Okay. And this is for all normal distribution. Okay, so you're going to use these same percentages for all the stuff in our homework tonight, because they're all going to be normally distributed. Any questions over that? Okay. Scrolling down. Okay, so use the data from the baby weights to create a normal curve. So we're going to create the normal curve here and use it to answer these questions. So our mean should be right in the middle. My number line's on the bottom. Alicia, what was the mean for our baby weights? 3.5 goes here. Okay. So our mean was 3.5. And then our standard deviation. Bailey, what was our standard deviation? For baby weights?
Oh.
Look at the other page. Yeah, let's do it 1.4. Let's see like that. I don't want to have a bunch of long decimals. So 0.14. Okay. So our next one is going to be 1 standard deviation away. So I'm going to add plus 0.14 to get 3.64. Then our next one is going to be slightly lower. And again, we're going to add 0.14, so 3.78. And there are one more standard deviation. It would be 3.9839492. Am I adding well, you guys? Oh, good. Okay, thank you. Okay, we're going to do that same thing on the other side, except for we're going to subtract. Now we're going to subtract negative 0.14. And again, we want to have symmetry. So we try and make our lines equal distance. Kind of like that. Okay, so this would be 3.36. This would be 3.12. 22, thank you. 22. And this would 3 point, what? Oh, wait? Okay. And so here's my curve, kind of like that. And again, we want to put the mean in the middle. Okay, make yours look prettier because a little bit harder for me to draw mine. For this, between here and here is 34%, and here is 34%. Okay. Then the next one is 13.5%, and then 13.5%, and then 2.5%. Any questions over that? Are we good? Okay, so now we're going to use this curve to answer these questions. So it says, what is one standard deviation from the mean, or positive? The plus means it's going to be positive to above, and that's going to be the 3.64. Does that make sense? Let's see. Nope. .64. And then one standard deviation from the mean, below it would be 3.36. Then 2 above, because it's the plus sign. So 2 above would be 3.78. Oh my goodness. And then 2 standard deviations below would be 3.22. Okay, do E and F on your own. Lauren, what'd you get for E? 3.92. Jalen, what'd you get for? Any questions on how you got that? We're all good? Okay. On the back. Okay, what percent of babies would be less than 3.36? Okay, so we want the percentage now for this one. Be less than 3.36. So that would be the 13.5 and the 2.5. So it'd be 16%. Any questions over that? Then what percent of babies would fall between 3.64 and 3.78? 13.5? Now this one says, if 200 babies were surveyed, how many would weigh more than 3.78? So what percent would weigh more than 3.78, class? 2.5%. Okay, but I don't want the percentage. I want to know if 200 babies were surveyed, how many? Okay, so I need to change this into a decimal. So we're going to have 0.025 times my number of babies, which is 200. And that will give me how many babies should weigh more than 3.78. And that should be 5. Any questions over that? Okay. We have one more to do. class at UCLA, there are 246 students. On their midterm, the mean score was 67% with a standard deviation of 8%. Okay? Assume the test scores follow a normal distribution pattern. Okay? And answer these questions. How many students got a score between one standard deviation of the mean? That we don't even have to do anything. What percentage of students should be within one standard deviation of the mean? Let's go back to our wonderful graph. What percentage of students should be between? 34 would be below, and how many would be above? 34, so how many total? 68. So how many students score between one standard deviation of the mean? So 68% should fall within one standard deviation of the mean. Okay, but it didn't ask me for the percentage, it asked for me how many. So I need to move my decimal over. So it's 0.68 times the number of students in the class, which is 246. Which is what? Let's just go 167, round. Because we're talking about people right now and I can't have a decimal for people. Okay? Now how many students scored above a 75? Okay, for this I kind of need my curve to see. So the mean score, I'm just going to do a rough, is 67. And I'm going to keep adding 8. So 67 plus 8 is 75, right? And then I would have another one and another one. So again, I need to know this percentage. What percentage goes here, class? 13.5. Rachel, what percentage goes here then? 2.5. So 13.5 plus 2.5 gives me 16%. But again, I asked how many students. So I need to move my decimal over. 0.16 times my number of students, which was 246. So how many is that? 39. 39 point what? Okay. Yes, so we're going to keep it at 39. Okay, then it says, where would a score of 62% fall in the standard deviation? I'm just going to complete this. So I have to do 67, I have to subtract 8 from there. And what would I get? 59. So how many standard deviations away from the mean does 62 fall? Here's the mean, right? So it's 1 below. Below the mean. Any questions over that? We're all good? Okay, 12.7 homework. You have lots of time.